Have you ever had one of those days where your tool looks like it's been through a war? I'm Jason with KYOCERA SGS, and today's one of those days for me. However, we're going to deep dive today into the machining mysteries of what's causing that damage. And we're going to really focus in on the two main culprits, speed and feed. So you might be wondering what's causing all this chaos. Is it the coolant? Maybe it's the programming. Maybe it's the fixturing, or it could be the tool holding. No worries, we're going to get to the bottom of this and Sherlock Holmes our way through it one chip at a time. When it comes to rescuing our tool from the brink of destruction, the quickest course of action, and typically where we start, is with speeds and feeds. Speeds are all about RPM, or revolutions per minute, and that's your tool turning or your part turning. Feed is all about the advancement of that tool into the workpiece. If you get those timed and synced together perfectly, you're golden. But if they're out of sync, things can go south really, really quick. Here's the kicker. It's not about taking your speeds and feeds to the maximum or bringing them all the way down to the minimum. It's about trying to find that sweet spot that allows you to maximize your productivity and your tool life. Most manufacturers will provide a speed and feed chart in their catalog, or some sort of application that you can find on the web. These provide a very safe and secure starting point for operating your cutting tool. However, there's a lot of variables that can occur inside the machining environment that can have a huge influence on the outcome of that tool's performance. Most speed and feed charts are a safe, conservative starting point. Oftentimes we'll push beyond these starting parameters to obtain and achieve maximum productivity. We'll do this until we encounter a negative result and then set our speed and feed parameters from there. In some situations, we have other influences, as we previously mentioned, that may be preventing us from achieving our productivity goals. We need to find that sweet spot between caution and speed demon. It's all about finding the balance. Too slow and you're burning through tools like nobody's business. Too fast, and well, let's just say explosions aren't just for action movies. So when it comes to troubleshooting, there's four major sources of wear. There's thermal, abrasive, chemical, and load. However, today we're primarily going to boil that down to two key categories, either heat or load. In this next demonstration, we're going to feed the tool into the part at a very conservative feed rate, exerting minimal load. While it's feeding into the component, we will incrementally increase the speed, showing you the impact that it has on the heat that's being created and generated during that machining process. In this next demonstration, we're going to reverse it. We're going to keep the speed constant and change the feed throughout the cut, much like the last demonstration. As the tool advances through the workpiece, we'll increase the feed to show you the impact that it has on the load exerted during that machining process. We're at the scene of the crime and we have to analyze the evidence. We talked about speeds and feeds and the sweet spot in regards to tool wear, but it also can tell us a lot about damage in regards to the tool. For example, catastrophic failure on a tool is often a load-related issue, or a build-up edge is where there's enough heat to allow that material to weld itself to the cutting tool. Or we could end up with cratering, which is a thermal chemical reaction, again brought on by heat, or edge chipping that can be brought on by load as well. Bottom line is we need to categorize how we're going to address that situation. We can think of speed as heat and feed as load, and start that as our process of elimination and investigation. Now that we've collected our evidence, we can narrow down our list of suspects. We can narrow down who the culprit is by analyzing the different aspects of the axes on this chart. As we can see, the vertical axis represents cutting speed, which again is a lead culprit in heat-related issues. The horizontal axis represents feed rate, which is the lead culprit in load-related issues. As we work around these axes, we can see, for example, material adhesion shows us very low cutting speed and very low feed rates, which basically means we've given the material enough time and enough heat to weld to our cutting tools. As we move to the top end of the cutting speed axis or vertical axis, we can see we got very high speed, very low feed rate, the main issue behind cratering. Working on along the horizontal axis, if we go to the far right of that axis, we'll see chipping and fracturing, where we have high feed rate and very low speed. Basically, this allows us to really identify the lead cause in all of these various forms of wear and damage. Always trying to work our speed and feed in balance to achieve that safe zone found in the center of this chart. So there you have it. Hopefully you found today's video on finding that speed and feed sweet spot helpful. Please comment and let us know what you might be interested in. Also, like and subscribe so you don't miss a future episode. I'm Jason with KYOCERA SGS, and until next time, keep those chips flying.